So I'm going to start with a little video, and we'll go from there.
The Audi.
What's up, working class America? My name is not Dr. Braeden MD. Today, let's talk about cholesterol biosynthesis, metabolism, and absorption, and what you can do to prevent hypercholesterolemia. So that way, you don't have to come and see me, so I can bill your insurance and further buy more expensive German imports.
I'm sorry, I kind of messed up there, but excuse me. Okay, so what is hypercholesterolemia? Remember back when we were in grade school and our teachers would tell us, break down the words, prefix, the root, and the suffix. So hyper, what's hyper mean?
Too much.
Too much. Cholesterol, what's cholesterol? Cholesterol. And emia, what does emia mean?
Concerning of blood.
There you go. So put it all together, hypercholesterolemia, excessive amounts of cholesterol in the blood. There you go. That's all it is. So why should you care? Well, obviously, as everyone knows, excessive amounts of cholesterol in the blood is going to lead to atherosclerosis and narrowing of the blood vessels, which you can see down here. So, in a scary statistic, the way everyone opens up the presentation with, in 2019, the CDC found that over 300,000 people died of coronary artery disease subsequent to excessive amounts of cholesterol in the blood. So who can it affect? Quite literally anyone. So there's a large genetic contribution to it. These are 4 main genes that I found attributed to it. So ApoB, if you remember back to the chylomicrons, how they had all those different APO, C3s, all the different lipoproteins on the outside. ApoB is one of those. Then LDLR, AP1, and PCSK9, excuse me. They all encode different proteins or lipoproteins pertinent to the absorption and metabolism of cholesterol. So on top of that, even if you're not genetically predisposed, diet and exercise is a huge contributor to hypercholesterolemia. So the suggested amount of exercise daily for a normal healthy adult is about 20 minutes of cardio exercise, which basically involves elevating your heart rate above whatever the resting heart rate is, and enough to just get you to sweat a little bit. So cholesterol absorption. So when we think about cholesterol, what macromolecular class does it belong to? It's fat. It's in the group with lipids and fats. So therefore, it means what can we say about the charge on it, or its solubility?
It's hydrophobic.
It's poorly soluble. So whenever we eat them, naturally, it's not going to be able to be absorbed very well into our gut. So why do we have these bile salts? Of course, they're amphipathic molecules that are going to allow us to absorb these into our body. So looking over here, glycolate, that's our main bile salt that we have. You can see the 4-ring structure that's just pretty ubiquitous to cholesterol itself, and then you get that big, long alkane arm, and then the carboxylic acid. That's the part that's going to sort of work to interact with the aqueous environment, but allow the cholesterol to be absorbed. So then we move on to triacylglycerols. So does anybody remember triacylglycerols? When you take them in, what's the first thing that has to happen in order to get them absorbed?
Break them down and take the glycerol and fatty acids.
Yes, exactly. So you liberate the glycerol backbone from the fatty acid tails. And you have to do that, of course, for the same reason we were talking about bile acids, of course. You can't absorb these big polar portions of the glycerol backbone across the cell membrane very easily. So it has to be facilitated through lipases, cleaving everything off. And then, of course, as energetically favorable as this sounds, everything's reassembled back together once it's into our body. Okay, so once these crude fats are inside of our bodies, what happens? Of course, they're carried to where they need to go by chylomicrons. So remember how I was just talking about them? ApoB, down there, that's 48. That's just a specific subset of the type of gene that I was talking about earlier. But regardless, anyways, does anybody remember where chylomicrons come from? So they got a lot of lipids, right? A lot of lipids. Where do we get a lot of free lipids from? Cell membranes, vesicles, sort of budding off, right? Remember that? Anybody? No? Okay. Awesome. Love that. Okay, and so on top of this, we see that this the structure of the chylomicron has a lot of lipids, like I said, and proteins. So because of that, what's the macromolecular classification? What class would that fall into?
They fall into fatty acids, lipids.
Lipoproteins. Very good, yeah. So then what? Okay, so now that we have it all absorbed into our body and it's able to move around sort of freely, what's going to happen next? Well, of course, all the chylomicrons are going to be predetermined where they're going to go, or they're going to bind to a receptor that's going to allow them to be absorbed into the peripheral tissues. As seen here in this picture, those protein components of the chylomicron are going to interact with the receptors and allow them to be endocytosed, as we talked about during the lecture. Okay, so now let's think again, bigger picture. Why do we store fat? What's the purpose behind storing fat?
So that we can use it later in the case of an emergency.
Yeah, okay. What did you say, Vu? Energy. Okay, so once we have it stored, does anybody remember what the metabolic process is called to convert fat into usable energy?
Beta oxidation.
Beta oxidation. Very good. Okay, so we're in the state of starvation now. We need that energy. What's the name of the hormone that's going to signal we need energy?
Glucagon.
Glucagon. Okay, so glucagon is going to bind to what kind of receptor?
Beta adrenergic receptor.
Beta adrenergic receptors are part of what kind of subset?
GPCR.
GPCRs. Okay, it binds to GPCR. And with GPCRs, as you always see, you end up getting ATP turned into cyclic AMP, right? Cyclic AMP is going to activate pKa. So that's just going to be a big old phosphorylation cascade. So it's going to start by phosphorylating the paralipin found around the lipid droplets inside of these adipocytes. And then you're going to get that huge cascade falling down. So after that happens, adipose triglyceride lipase is going to be activated. And that's going to take your triacylglycerol into a diacylglycerol with a free fatty acid. And it's going to follow the same sequence going down to phosphorylation of hormone-sensitive lipase, which can be diacylglycerol liberated into monoacylglycerol, free fatty acid. And then the last step, monoacylglycerol lipase is going to be activated by phosphorylation. Monoacylglycerol is going to be liberated into glycerol and a free fatty acid. Then after this, who remembers what the most abundant serum protein in our body is and what it does?
Albumin.
Albumin.
Transport fatty acid and act as a carrier protein.
There you go. That's it. Okay, so how can you treat hyperlipidemia or hypercholesterolemia? So I did an interview with my primary care provider over in Andover, Dr. Carrie Klaus. She's awesome, 10 out of 10, recommend her. So Dr. Klaus said, chronically elevated levels of cholesterol and other fats are a primary concern of mine when treating my patients. Elevated cholesterol can be a snowball scenario in terms of types of issues it can cause later down the road. My first level of go-to treatment is assessing a CBC blood panel to determine the serum lipid levels, usually the LDL and cholesterol levels first. From here, Dr. Klaus also stated that she doesn't have a set guideline for each patient and all patients are different. She did mention that usually a statin will be the first line of defense, followed by dietary and exercise modifications. So what is a statin? What is a statin? Of course, they're a class of drugs that are used to treat hypercholesterolemia. And how do they work? Without looking at the screen. Without looking at the screen. Anybody remember what the enzyme is called that they antagonize?
You're white.
HMG-CoA reductase. That's right. Terrific. Okay. Wow. So why is it? Does anybody remember why it's important or why it's favorable to target HMG-CoA reductase? What's special about that step specifically in cholesterol synthesis?
It's the rate limiting step.
It's the rate limiting step. Exactly.
That's always the right
Excellent.
answer in biochemistry.
It is, yes. So, excellent. I'm so glad that you didn't read the...
I didn't, no. It's,
Oh, you did?
it's like Dr. Beck said, yep.
Good job. Excellent. Okay, so here's just a little schematic from Dr. Beck's presentation she gave us. I went on ahead and used your stuff, so thank you for that. So by inhibiting the rate limiting step, it's basically the best way to assure that you're not going to get any newly synthesized cholesterol in your body. The main source of it is going to be from dietary sources. So just think about it for a second. You know, if you have a really unfavorable, chemically unfavorable reaction happening and you're inhibiting the enzyme that's going to catalyze it, you're not going to get much random production of the subsequent product. So now on the contrary, we know what happens if you have too high a level of cholesterol. So what happens if they go too low? A study performed by the American Heart Association in 2012 found that chronically low levels of serum cholesterol have been strongly linked to the incidence of atrial fibrillation or AFib. In addition to this, a study performed by the Mayo Clinic Also found that chronically low levels of serum cholesterol have been linked to different types of cancers, hemorrhagic strokes, and severe sudden depressive episodes. Yeah, I'd be depressed too if I couldn't eat cheeseburgers. Okay, so because of the prevalence of, this is where we're getting back into the cash cow called cholesterol. This is the part that I was like actually blown away by. Because of the prevalence of obesity and hypercholesterolemia in the United States, it's reported that Pfizer alone, the brand name manufacturer of Lipitor or atorvastatin, is one of the most common statin drugs that you'll see prescribed, generates $2 billion annually of revenue just from Lipitor alone. $2 billion. So, you can combat this, of course, by like what Dr. Klaus said and what I've talked about so far. You can combat this with proper diet and exercise. And if you're concerned about your health or well-being, I'm just basically going through the legal jargon and saying, I'm not a doctor. Do not take any of this as serious medical advice. Go talk to your doctor yourself. So, and here's the very last video. Hi, working class America. It's not Dr. Again. As you can see, I'm currently having to work in pharmacy because I lost my job as a physician because all of my patients were taking my illness way too seriously. And now everyone has atrial fibrillation because they got their cholesterol under check. So here I am making an amiodarone for someone. It's unfortunate because I can no longer afford my obsession with my expensive German imports. But I guess that's just part of it. I'm glad to see that people are taking my warning very seriously though. When in doubt, always remember, it's always pharmacy's fault. That's not there one time. Pharmacy's fault. If the order got messed up or put it in correctly by the provider, it's pharmacy's fault. And don't forget. Hi, working class.
Is that what your experience is like?
Yes.